In this video, we're going to look at some properties of rational functions when there are no exponents in either the numerator or the denominator. So we want to be able to find the domain and the vertical asymptotes, both of which come from setting the denominator equal to 0 and solving it. If there's no solution to the denominator equal to 0, then there would be no vertical asymptotes and your domain would be all real numbers. For our range and our horizontal asymptotes, we're going to use the rules that we had about the degree of the numerator and the denominator. So if the numerator degree is smaller, then the horizontal asymptote is y equals 0. If the numerator degree is bigger, then there's no horizontal asymptote. If the numerator and denominator degrees are equal, remember we divide the leading coefficients. And then my range is going to be all the numbers except for the value of the horizontal asymptote. So looking at some examples. So for this f of x, the first thing we're going to do is take the denominator, set it equal to 0, so x minus 2 equals 0, so x equals 2. So that's the number where my vertical asymptote is, and it is the number that I have to remove from my domain. So my domain is going to be all numbers except 2, so I'm going to do negative infinity to 2, and then 2 to infinity. My vertical asymptote then is going to be at x equal 2. For my range, the degree of my numerator is 1, the degree of my denominator is 1, so I'm going to divide my leading coefficients, which are 3 and 1. So I have a horizontal asymptote at y equal 3, which means that my range is all numbers except 3. So my range is going to be negative infinity to 3, and then 3 to positive infinity. We're going to take a look at the graph just to confirm some of these things. Remember, when you type in a rational function like this, put it in parentheses, or you can use the fraction notation in your calculator. So we're going to do 3x minus 7 in parentheses divided by, and then x minus 2. So taking a look at the graph here, we came up with that the vertical asymptote was at 2. So we're going to do second trace value at x equal 2. Y is undefined, so that's a good confirmation of that for us. And then we believe that our horizontal asymptote is at y equals 3. I'm just going to kind of graph that. So I'm going to go back and I'm going to put y equals 3 in for my y2 and just see if that matches up on our graph. So that does appear to be my horizontal asymptote. So it's a nice way to confirm your solutions that you got working algebraically. So looking at the g of x function, we're just going to go through the same process. So x minus 1 equals 0, so x equals 1. So my domain is going to be all numbers except 1, so I'm going to go negative infinity to 1, and then 1 to positive infinity. The degree of my numerator and denominator, again, are both 1. So I'm going to say that my horizontal asymptote is at y equal 2, because again we're going to do those leading coefficients. I forgot to write down the vertical asymptote, so the vertical asymptote is at x equal 1. And then my range again is going to be all my numbers except where my horizontal asymptote is, so negative infinity to 2, and then 2 to positive infinity. And on the last one, we are going to look at the denominator, so x plus 3 equals 0. So that gives me x equals negative 3. So my vertical asymptote is at negative 3. So vertical asymptote x equal negative 3. I'm going to remove negative 3 from my domain. So my domain is all numbers except negative 3. In this case, the degree of my numerator is 0 because it's a constant. The degree of my denominator is 1. So my numerator degree is smaller, so my horizontal asymptote is going to be at y equals 0. So then my range is going to be all numbers except 0. So negative infinity to 0, and then 0 to infinity.